Hello. Okay, here we are. I think that it's time to start, and I only have 30 minutes. So the title of my session is The New AI Frontier in FileMaker. So I was not really sure what to talk about because, of course, you have to have an idea what to talk. I mean, 2 or 3 months ago when there is, you had to submit your proposals. So AI is changing so quick that now I change a little bit and I try to focus on 2 interesting things that I hope you will enjoy and learn a little bit. Okay, who I am, first of all, I'm Nicolás Franco. Some of you, then you know me. I am, as a base, I am PhD in physics. I've been teaching physics for many years in different universities. Actually, I'm assistant professor at the Polytechnic University in Madrid and another private university. I've been assistant professor in USA also. I am a partner at Bitwalk. Bitwalk is a company that is part of a bigger company. Its name is Houston. We have different departments, and we have a specific department for working on FileMaker. That's since more than 25 years or something like this. So we are able to really mix different technologies because we have an AI-specific department, very technical, very mathematical department. So we work on projects on AI that are very complicated at the mathematical point of view. So we have, we can have a good idea of what is working, I mean, how it works, AI, and this is what I will try to explain today. So these are the new features of FileMaker, AI in FileMaker, some of them, and not all of them, but the most important: natural language database queries, semantic search, automatic extraction. That's it. So, and 47. I have 30 minutes to try to play. Those are the more used, if you want, by most of the people that are not familiar with AI because are very, no, I would not say straightforward, but they're much more easy to use. And I will try to focus more on the other ones, the LLM integration. That is not, let's say, difficult, but RAG integration and fine-tuned models is a bit more complicated. So because you have to take into account different things that I will show today. Right? So because now I have 20-something minutes, I will try to go fast. So try to pay attention. And of course, I apologize my English. My English is not very good, but I hope you will understand. So let's start with the native LLM model integration. Why we have to integrate LLMs? First of all, is the most important point for me is enhanced security because you have your model on local, so you don't have to share your model with other, let's say, you can securize much better. This is the first point that is the most important one, but this other one, cost efficiency, of course, even if we think that AI models, I mean, when you put outside is cheap, it's not cheap, it's expensive. When you have huge models and you have really on production, it costs quite a lot of money. So you have your own model integrated, you only have, it's much less expensive. And this is one point that, on large, this is very, it's very important, right? Data control, of course, because when you have your own model, you can control by this fine-tuning, or you can have much more control than a general model that you don't integrate on your system. And last of all, performance. Performance, you will say, okay, even if I am not on local, I can, on Amazon Web Service or whatever, I can perform whatever I want. Yes, but it costs, and of course, in case you can optimize the performance for your model. This last point is not the most, let's say, is the most important one, but it's also one we have to take into account. So there's 2 ways of integrating LLM models. The first one is the difficult one. The second one is the easy one. The first one, there is a video by Shandon Froggett that I found that is very good, is using LM Studio. LM Studio, you can directly download your model and try. You can Dockerize in your computer if you want, and with Oyama, you can download models from Oyama. So you can directly use LM Studio to download on your computers your model, and after with API, you can call your models directly on your computer. This is one way of doing. It's very good because you can take outside really of FileMaker all your model, and you can customize, but it's a little bit more complicated. And the second one is the one that in the last version of FileMaker they introduced, that is go directly to Hugging Face and download the model of your Hugging Face with the FileMaker server. Hugging Face, you know, is a platform when you can have billions of different models. And one thing that is good that you can, depending on your infrastructure, if you are using PC or Mac, depends of how it runs. You know that you need these GPUs for running the models, but in case of Macintosh, the architecture is completely different. Not completely, but it's a little bit different. So you can use specific models that are trained for those models. They say the Macintosh infrastructure has specific GPUs that are not named GPUs, but they are mixed with the RAM memory, so you can use those models specifically, so you can find in Hugging Face specific model for infrastructure. So this is the two ways, and so what you do, this is very easy. You have to download your models. By default, there's already some models that are not downloaded, but are added to the platform. You have to do two things, that is download and loaded. You cannot, there is different kind of models, of course. You have text embedding, you have text generation, and you have image embedding. In case of you don't know the difference, the text embedding, we will talk on what is the embedding and what is the different, the different kind of embeddings. And text generation is the one that is much more, let's say, expensive on weight, and you have to be careful when you download it, depending on your infrastructure. You need very heavy computers if it's in local, okay? And of course, you can, but this is the second part, is you can not load. You can unload any kind of model you want, but you cannot load two models of the same kind. But this is one of the things, of course, because you will use only, it's tricky. I was thinking, why we don't have different models, let's say text generation models, and to use one for one task and another for another task, but you cannot load at the same time. If something makes sense because they're very loud, right? Okay, the integration is very easy. You can go step by step, and you can configure. You have to configure your account. It's very easy. This is not very complicated, really, to do it. And the only thing that really perhaps you should take a little bit careful is two things. That is, you have to try to use your specific server for the AI models. Let's say if you have one specific server for your data, for your FileMaker, try to use another one, because other case it will be overloaded, that you will not be pushed, it will not work very well. And this is something that this morning I was thinking about, but because if you need a server for your data, another server for your AI model, and probably you will need another servers for the new configuration, that is for the backup or for the standby server. At the end, you need 3 or 4 licenses for all your servers. And I don't know if they have to think about what is the licensing model, because if it's a small company, you cannot afford to buy 4 licenses for one server. But in this case, of course, this is more or less is thought for very big companies, or at least big companies, so they can allow to pay more than one server, right? Okay, and hardware. What do you? Depending if you are using Windows, Ubuntu, or MacOS, The hardware is a little bit different in the sense that you have these Apple Silicon CPUs, or you have those Intel different processor. So what is very, very, very important is the RAM amount. I mean, the RAM is extremely important because all the models should be on the RAM. So if you want to download the model that is, let's say, 16 gigabytes because it's a heavy one, you need to put everything on RAM, plus the operative system, plus you need the RAM that you need to run the model. You need at least 32 gigas or more. I mean, 32 is the minimum, but I mean, in our case, we found out that 48 gigabytes is really the minimum if you want to work a little bit. So it's very expensive on RAM, and it's really the point that you have to spend money on it. And one other thing that is the fine-tuning, I will work a little bit, I will talk a little bit later. There is only supported by Apple Silicon and Apple Silicon Ultra. You cannot use those fine-tuning with other machines, something that is, is a pity, right? Okay, this is the first part of 3. I think that I am on 10, 56, yes, I need 14 minutes more. What is a RAG? And now that is, I'll try to explain very quickly what is a RAG, something that is a little bit difficult to explain in only 5 or 7 minutes. RAG, what the name says, Retrieval-Augmented Generation, and what you say usually is when you make a query to your LLM, you want them not to. As you know, the LLM is completely, let's say, and apologize for the word completely stupid, they don't understand nothing, but they give you calculation of let's say, tokens. So when you ask them something, they don't understand what you're asking. So it's much better if you ask something that is very specific to go to a database, grab the data, and give you back. And what is very good, the LLM, is to put on a sentence or explain you in a good way. But the data itself cannot really understand what you're talking. So what we're doing with a RAG is to put all the valuable data in a database, and this database be able to, before anything, be able to the LLM to understand what database you have to choose, go the data, and have to construct the sentence and construct everything that you want. This is a RAG. But the important thing is that here with the RAG implementation in FileMaker, there is one problem. There's only one database that you can use. Most of the time for the RAGs, what is good is to try to use 2, 3, 4 different databases, and after have a kind of discriminator that is going to one database or to other to take the data and coming back. In this case, there's only one database, but it's enough. So what you do, there is a user to have an input, you query this processing, and the RAG is this Retrieval-Augmented Generation. What does it mean? You retrieve the data, you augment the information and with your original query, and you generate with LLM. And this is the idea. So there is difficult. To do this, you have to take into account 2 things that you have to do outside the FileMaker. First of all is the chunk. Of course, you think that, I mean, the examples that are giving us is they're giving, let's say, invoices. Invoices is a piece of text that is very small. But what about if you want to put really PDF that has hundreds of pages? You cannot put it all together because you cannot tokenize a long text. So what you have to do is to chunk. It means to cut on different pieces. This is not done by FileMaker. You have to do by your own. So how do you do really this chunking? And this chunking has to be done outside, and you have to be careful. You can be done by a script, or it can be done with different other functions outside. This is what we do usually with other programs, where you take your text, you chunk, and after it goes to FileMaker, because FileMaker doesn't allow to chunk a big text. This is a very small one. Why do we need to chunk? First of all, because overcoming this window limitation. I mean, when we have to come this context window limitation, what does it mean? It means that usually you have, for all the models, a number of tokens that is the window. You cannot have more than those tokens those window token, and you have a maximum output and input of token. So you have to cut on pieces your document in order not to overload this number of tokens. And also, you have to improve the signal-to-noise ratio. I mean, when you cut on pieces, if you don't cut in a good way, you have a lot of noise, and the signal is in the middle of the noise. So what you want is to cut just in the parts that becomes to the same kind of information. If you have a document, you don't want to cut in different places without paying attention where are the information that is specific, and cut in the parts where the information is specific, no? And also you need to enhance this retrieval efficiency. It means that it's the same, this point and the before point. It means that really in both ways, I mean, the information that when you are cutting the information, you are chunking the information, has to be done in the areas where they are talking with the same. And this is very important because for the model, it will give you much better results. And last of all is for the task-specific optimization. It means depending on what are the tasks that you will use in the future for this model, you have to cut in the places where they need to do something very specific. It means if you want to retrieve information for one specific area of your document, you have to chunk this area very in an isolated way, very nuclear way. Other case, it doesn't work as much. So this is part of the chunking. There is different techniques. One is fixed site chunks. It means you give the number of parameters and you cut, and that's all. That you can do it with FileMaker. This is easy. The second one is recursive or hierarchical chunk. It means that you are cutting on pieces of paragraph of something like this that are more hierarchical one. That is not bad. And the third one is the one that is the better one, that is semantic chunking. I mean, only parts that are talking about the same information. So you have to pass your your text through an LLM and tell him where are the parts that are important, so they chunk all those parts. And this is what is important. This one, you have to do it outside FileMaker to go to a model for chunking, chunk and coming back. And this will give you extremely good results. The other one can give good results, but this is the best one. Okay, so once you have this chunk, you have to, with this pieces of data, you have to embed. Embed, what does it mean? It's convert to a vector, because what you will do in the future is try to see the similarity of different vectors. And it's a mathematical model. It's not a linguistic model, so you need really to understand what is a vector and convert everything on vectors. These embedding models, you have audio, text, video, whatever embedding ones. On here, in FileMaker, we only have two kinds of, let's say, models that we're using, that is text or images, video, but you have many other kind of embedding models outside for using. What does it mean, an embedding model? An embedding model the first embedding model was the Word2Vec. Word2Vec was built by Google. Most of the good stuff has been built by Google. I don't know why Google, they are not taking advantage of all of this, but most of the technologies has been built by Google 10, 12 years ago. This was 2013, and this is Word2Vec. What they do is they take and they vectorize the word and take into account what are the words that are close to the sentence, so the ones that are very close one each other. That was the first embedding model. And they were taking in, there was two kind of Word2Vec, continuous bag of words and skip gram, depending if you are taking into account the words that are after or behind the word that you want vectorized. And after it came to the University of Stanford 2 years later, I think it was 2014 or 15, something around, and they built this globe that is global vector for word representation, and it's the one that we have always in mind, because this is really a multi-spatial generation of vectors. And it was working very good until this famous paper of Attention is All You Need of Google in 2017, that is the birth the bird model. The bird model is the first bidirectional encoder representation and the transformers, and these give you not only what is the vectorization of a word, but it takes into account all what is the attention. It means is a model of attention. Is what does it mean? The whole sentence and the whole paragraph, and he put this vectorization all together. And there is OpenAI who came with the GPT, that is the pre-trainer transformer. This model is a pre-trainer, and it gives you one vectorization model that is the one that most of the time we are using. Some of this kind is GPT model vectorization. So when you have this rack integration, as you say, you have to give some kind of parameters. It's not complicated at all, but you have to understand what does it mean. Number of ranked results, it gives you, of course, the number of results for the vectorization. And after you have the cache, the rack cache path, you have to tell them where is the cache, if you want to use it faster. And you have to tell them the embedding models. You can use the OpenAI embeddings or any other kind of embedding models. And it's very important because the embedding models give you really technically what is more efficient or not. Let's say for the embedding models, using good embedding models, depending on the data that you have, is very important. So you can load an embedding model and for using. And I have 10 minutes, that's good, I am on time. And the last one is fine-tuning models. This is a little bit more complicated than the other ones. And fine-tuning, what does it mean, fine-tuning? Fine-tuning, it means that we have an LLM model that you have, as I don't know if you remember, or I gave a couple of talks about how that was working. Is a model, is a mathematical model that's only a function with a lot of parameters. It's very easy. It's very easy. The function is only a linear function with 1,000 billions of parameters, but it's a linear function. And all of those parameters are being trained on a network, and has been trained to optimize, this function. So, but had been trained with general data. And at a certain point, you want to fine-tune, let's say, to train, again, with your own data, but you don't want to train the whole model because it has zillion of parameters and it's very expensive. You want to train only with a part of those parameters. It means that you have this large unlabeled corpus that you train your LLM, and you have another small labeled corpus, and this one you want to fine-tune your model. It means that it's cheaper because you only have to rebuild those parameters with a small corpus, and doing this, your model would be much, much more efficient, extremely more efficient. So at the end, you have your LLM with another created data set and this fine-tuned LLM that is the one that you use for your purpose. Okay? So what you have to do? You have to do, first of all, you have to prepare your training data. And prepare your training data, what does it mean? It means that if you, for example, you have a database and you want to train for medical purpose, you have to really ask questions and have the right answers and to put everything on a JSON object. It's not really a JSON, it's a JSON line object. It means that you have to format every line for a single data. It has a little bit different structure because each line is an example of a question and answer structure. So it's a JSON data. So what do? You need to have this structure of, let's say, thousands of question and answer of everything that has been done, depending of the structure of your database. But you need good question and good answers to your database. And you format on this LLM, this JSON line format, and you go to the fine-tuning. As I told before, you can only fine-tune one model if you have this Apple ML architecture. You cannot do it on a PC, but in the section, you only have to give a name, give the base model, what is the base model that you use for the fine-tuning, and you have to give the number of iteration. Of course, the number, if the number is increasing, the time is increasing in your machine, and the LoRa layers. I will talk now what is about LoRa layers and the batch size. And in the browse, what you said, you have to load this JSON line file with all the question and answer. And what is So to configure those parameters, you have this number iteration, linear data, batch size, and you can apply techniques like LoRa. What is LoRa technique? LoRa technique is what we say parameter efficient fine-tuning technique. It means that, of course, you have to try to take your database, your LLM, and say, okay, what of those parameters really I need to retune? Because I don't want, if I have 10 billion parameters, I don't want to retune all those 10 billion parameters. So what do you do is to take one set that is a trainable set, and this set is the one that you don't retrain all of them, you retrain only a part. And what part is the one that you train? In fact, the LoRa take into account the part depending of the data that you are giving. Let's say if you are giving medical data, the ones that are more, let's say, similar to medical data is the one that they will retrain. So the LoRa, what they say really is they don't take the whole bunch of parameters, they only retrain a set of parameters that are more similar to the ones that you are giving to train. And this is what is important, that you have many other techniques. LoRa is the most common one and is the most not efficient one perhaps, but is the most common when we have a general data set that we don't work for specific instructions. So once we have, now that you understand more or less what is LoRa, you have to run the fine-tuning. Let's say you only have to run, and we can have this final model to use it with our solution, the one that we want to use. So finally, at 12, okay, I have 3 minutes left for my help. The conclusions is that, okay, we have a lot of new features, but that are extremely powerful, but they're a little bit complicated to understand and to use it. I am not pretty sure if when they put in place they were thinking of the big majority of FileMaker users, because I think that most of the people that are using FileMaker, they will not really use those, at least this RAG and fine-tuning functionalities, because they are a bit tricky and they expend time. Also, you need a specific infrastructure, and it's a little bit complicated. But this is also another point that you have to take into account. The infrastructure is, or you use something in the cloud that is expensive, or you buy. And in our case, if you want to buy, a computer for fine-tuning, you need at least 6,000 euros. It's around between 6 and 10,000. It's expensive. So if you are not pretty sure that we'll use it, it's something expensive. But if you learn how to use properly, it can give you extremely nice and good result, and you can leverage really everything. Your use of AI. So it gives me 2 minutes for questions, if someone has, and thank you very much for your attention. No questions? Vincenzo?
I have short legs, I'm not fast.
Okay. So when you generate you break up, what is it called when you break? Chunk it, right? So, when you rely on the third method, which was the AI one?
No, yeah, usually what we do is the documents that we have to tokenize, first we go outside, and with Python and other process, we chunk it. We don't chunk it with FileMaker. And because, I mean, in our case, we had a project that is people that are, doing those ICO, that is those documents that are 300 pages or whatever. And this is extremely, and after, with those documents, you can put on, you have to chunk, tokenize, and you can ask with a RAG. But if you don't chunk properly, you can have any kind of results. But this is for 200, 300 big papers, and most of the time, this is extremely important to chunk it very well and to chunk in the part. And we have an external model of LLM that help us to chunk it in the parts that mean in the same sense, and this is important. But everything we're doing outside the FileMaker.
Thanks.
Yeah. The same, one after the other.
Please, how do you evaluate the efficiency of this method? And
the evaluation of the method is, at the end, depends, it's the client who will evaluate. We put on place, we have, now, for example, we are having a project, and we are doing this chunk, and they have to ask for this document some kind of queries, and they have given, if the results are more than 85, 87% of the time is good. It has to be between 87 and 90%. More than 90 is very good. More than 95% is extremely good. And this is what this evaluation. Less than 82% is not good because it's not valuable for the client. This is our evaluation. But depends of the project, depends of, and in our case, we see that, for example, if we don't chunk very well, our ratio in this project goes down below 70%. The chunk was one of the really the things that we were working a lot in order to have good results in this kind of problems. This is why I say it's very important, and nobody is talking about, because I think that in the mentality of FileMaker solution is not to put this kind of functionality, a big document, is to have invoices or to have small documents. And for this, you don't need to chunk, of course. But if you have very big documents, you have to chunk. And this is why probably in the future they will have it. But it's not perhaps in the mentality of functionality that they have in place Claris. I don't know. There was another one.
Which amount of data do you need to efficiently fine-tune a model?
Fine-tuning. Depending on the model that you have. If you have a model that is very expensive, you need at least thousands. With 100 is not enough. If you have a small model, any kind of small model, MLX, a small model, whatever, perhaps with some hundreds, you can have it. But below 100, no. And depend. But the amount of questions you need is over 100 if the model is low, and over 1,000 is a big model. It's one of the big models that you can allow that is perhaps 20 gigas, 15 gigas, 20, 30 gigas, you need 1,000 of. Because it depends on the model and the number of parameters. That's it. Okay. Thank you very much again. And if you need have any other question, I will be here around.